I want to talk about how we could solve systems of equations with what is called elimination method. And first of all, let me just remind you, I know we've talked about this in other videos that I've made, but solving a system, what that really means is finding the coordinate where these two equations intersect one another. That's what we're looking for, an intersection point. So knowing that we're looking for an intersection point, we need to give our answer as a coordinate, x and y. What are x and y equal to? Now, elimination method, to me, works best when our equations are given in standard form. Standard form for lines means that both x and y are on the same side of the equal sign. This works really well for word problems. These types of problems are really, really common when you add context. You know, I sold 2 of this and 4 of this and I made $10. I sold 2 of this and 6 of this and I made 14. How much of each did I sell? So it works really well for that. Now, I want to show you quickly what this method kind of does, but then I want to show you the faster way we can do it. So let's start with this. We have 2 equations, right? We've got our equation here that's equal to 10, and we have our equation here that's equal to 14. So what we start with is focusing on the 2 equations. We say, okay, this equation and this equation. What if I were to subtract them? So I were to take my first equation and subtract my second equation. Well, if I did that, that would be the same, since the first equation is 10 and the second equation is 14, that would be the same as subtracting 14 from 10. So I could say it's equal to 10 minus 14. Again, I just want to say this first equation was 10, so we're saying the first equation is 10. We subtract the second minus the second, which was equal to 14. Now, if I just go through and now simplify this, so let's get rid of my parentheses, multiply that negative through. 10 minus 14 is negative 4. You notice 2x minus 2x is 0. 4y minus 6y is negative 2y. Divide both sides by negative 2, and I have solved. Y is 2. Then I go up to the other equation and I say, well, if y is 2, if I know that y is 2, I could say, well, 2x plus 4 times 2 equals 10. So 2x plus 8 equals 10. Subtract 8. Divide by 2. X is 1. So my coordinate is 1, 2. Okay? That's what we're doing here. We're using kind of this equality, like if this equation is 10 and this equation is 14, if I just find the difference of each of those, that's equal to the difference of the numbers. Let me show you a faster way we can set this up. So I'm back to this. And again, I'm not doing anything different than the way I organize my information. I subtracted the second equation from the first. 2x minus 2x is 0. 4y minus 2y was negative 2y. 4y minus 6y, was negative 2y. And 10 minus 14 is negative 4. Y is 2. I already have solved for x. X was 1. But this is a faster way to do the same thing, but just organize the information a little bit quicker. Let's do another example. So in this example, what you'll see is that I don't have something that can be as quickly subtracted, because if I were to right away subtract, 3x minus x would be 2x, 4y minus 6y would be negative 2y, 18, but nothing would subtract out. I would have stuff left over. So it wouldn't be a process. I mean, the nice thing about the previous example is one of the variables was gone. I'm going to make that happen. Let me explain. I'm going to take this second equation and I'm going to multiply it by 3. Now, The top equation I'm not going to change at all. It's going to be 3x plus 4y equals 18. But this second equation, I'm going to multiply each piece of it by 3. Now, what does that do to the line? The answer is absolutely nothing. It still has the same y-intercept. It still has the same slope. All I have done is changed, multiplied each number, but I haven't changed any of the values on that line because I was consistent and did it to each piece. So if you think about like solving this for y, if you wanted to put it in your y equals form, subtract 3x, divide by 18, those numbers, those y-intercepts and slope, will reduce to exactly the same thing it would have over here. I didn't change anything. But I made it so that when I subtract, that variable is gone. 4y minus 18y is negative 14y. 18 minus 60 is negative 42. Divide both sides by negative 14. Y equals 3. Now remember, we need to figure out what x is. There's no difference in which equation you pick. For my consistency, I always pick the first one, but there's nothing wrong with picking the second one. We know that y is 3. Then just do a couple of steps here. Subtract the 12 over. 3x is equal to 6. Divide by 3. That is 2. So my point, x is 2, y was 3. Make sure and get them in the right order. So we can just scale in order to make that subtraction happen. That's what we always want to do. We always want to make it subtract. Let's do another example. In this example, what you see is that it doesn't really look like I could multiply this one. I mean, I could multiply it by a decimal to make it 5, but that's not great. I don't really want to deal with that. But here's the thing. What we did in that previous example where we multiplied one of them to create the subtraction, we can actually multiply both of them to do that. And I'm going to do that. And for ease, I typically just focus on the very first variable. I just say, I'm going to subtract out the x's. So I'm going to multiply the top one by the coefficient here. So I'm just going to say, well, 5 times 2x, that'll be 10x. Just make sure and do it to everything. Of course, 5 times 0 is 0. And then I'm going to multiply this one by the coefficient on x of the other. So when I do that, 2 times 5x, 2 times 6y, 2 times 7. Now, when I create this big subtraction, again. Now, there's nothing special about subtracting off the x's. I certainly could have focused instead on, creating something that would have subtracted these out. I kind of like the consistency of always doing the same thing. Doesn't matter. All right, 20 minus 6y is 14y. 0 minus 14 is negative 14. Y is negative 1. Go back to an equation, say, all right, 2x plus 4 times negative 1 equals 0. Add 4 to both sides. Divide by 2. So my point, x is 2, y is negative 1. So again, this method, we're solving a system, we're looking for the intersection points. Elimination method really works best when we have two lines in standard form, meaning both x and y are on the same side of the equals. And just remember, we can scale, we can multiply our line. I did this one by just the coefficient here in order to get 10x. I did the second line by the coefficient here in order to get that common coefficient so that subtraction led to 0. Just be careful and subtract or multiply at each piece, subtract and solve, and don't forget to go back and solve for the other variable. If this video helped you, please like and subscribe for more math help.